in an event. So similarly, the products can be defective or not defective. All right, so the second condition is that the events must be mutually exclusive and collectively exhaustive. The third condition is that the probability of if please take note that here we are using the symbol for probability as pi. So don't get confused this pi with the mathematical constant. Okay, so this pi is referred to the probability of an event, okay, in which we are looking. So the probability of an event is pi is constant from observation to observation. So that means for all the observations, the probability of the event must be a constant. So under these three conditions, okay, the last one is the value of any observation is independent of the value of any other observation. So all observations must be independent from each other. So under these four conditions, we can apply the binomial distribution, a probability distribution. So binomial probability distribution is a mathematical model. So relates the number of observations with the probability pi. Okay, if the probability of occurrence of an event is pi, then the probability of the event not occurring is 1 minus pi. Okay, so because the events, the condition 2, so we are dealing with collectively, mutually exclusive and collectively exhaustive categories. So under these two categories, if the event probability is pi, then the event not occurring, the probability will be 1 minus pi. Okay, so under these four conditions, we can apply the binomial probability distribution. Now let us look into the, okay, where we can apply. So there are many cases, for example, in manufacturing plants, okay, to find out the product defects, okay, product rejects, okay. There are many cases where we can apply the binomial probability distribution. So binomial probability distribution requires counting techniques. So we look into the formula now. So we know that the counting techniques, when we are dealing with X objects from N objects, okay, the number of combinations you can expect will NCX, so which can be written as probability of factorial n over x factorial into n minus x factorial. So this formula we have seen earlier under counting rules. So I clear this, move forward. And okay, so this is an example again for counting rules. So this example says, so how many possible outcomes you will get when you have 3 scoop combinations, okay, from 31 flavors. So the number of flavors you have for ice creams are 31, and you want to get 3 scoops from this 31 flavors without, no flavor can be used more than once without repetitions. Okay, so you have n is equal to 31, then x is 3. So the number of combinations we get is 31C3. So that means 31 factorial over 3 factorial multiplied by 31 minus 3 factorial. So we can do, we know how to do this calculation. So we can write 31 factorial over 3 factorial into 28 factorial. So now we can cancel this 28 factorial. So the final answer you can get is, so when you are using 3 scoops from 31 flavors, so there is a total number of 4,495 variations are possible. So the sample space is 4495. So this is how we can use the counting rules for combinations. So why we are doing this again? Because binomial distribution involves this counting rules. Now mathematically we can express the binomial distribution as shown here. So we can write the binomial distribution as the probability of, okay, X, okay, an event given the sample space, okay, the sample size and the probability. So the probability is pi and n is the sample size. So you are calculating the probability of an event X. So this can be given as, okay, so factorial n, because we know n, okay, and the X we are calculating, therefore we know X also, over factorial X into n minus X factorial. So the whole thing is your counting rule for combination. So we can write this as n C X, then multiplied by the probability pi to the power of X. Okay, and multiplying this with 1 minus pi. Pi is again the probability, so 1 minus pi to the power of n minus X. So if you look at this, this is how we can calculate binomial probability for an event X. Given the sample size, given the probability of the sample. Okay, so we'll be using this calculation, this formula to calculate the binomial probabilities. So you need to know how to do the calculations given n, x, and pi. Okay, so this formula is important, and a number of times we'll be applying this formula. So this is the mathematical model for binomial distribution. So binomial distribution is part of our discrete variable. So discrete probability distributions. So we apply binomial distribution when we know sample size and the probability, and the events have the equal probability, and the events are mutually exclusive and collectively exhaustive. So all the conditions must apply. So this is how we can define mathematically the binomial distribution. So X represents the number of events of interest. So X is a variable, okay? N is a sample size. So this is number of trials or observations. So pi is the probability of interest. So we'll be knowing what is the number of trials or the sample size. And also we'll be knowing the probability. So we can calculate 1 minus pi, the okay. So for example, here you can see if you flip a coin 4 times, okay. So let X is the number of heads, okay. So when you flip a coin 4 times, so the sample size is 4. So the probability of getting a head is 0.5. So we know pi is 0.5. So 1 minus pi is again, so 0.5. So when you flip a coin 4 times, so the probability of getting a head, okay, you may get all the 4 times tail. So there is no probability of getting a head. So that is 0 probability. Okay, you may get 1 head and 3 tails, or you may get 2 heads and 3 tails, or you may get 3 heads and 1 tail, you may get 4 heads. So these are the probabilities. So the variable X can be 0 or 1 or 2 or 3 or 4. Okay. So this is the meaning of binomial probability distribution. So I cleared this. Now let us look into how we calculate the probability distribution, binomial distribution. All right, so this is how you can calculate the binomial probability. So let us read the problem. So what is the probability of 1 success in 5 observations? So n is equal to 5. So what is the probability of 1 success? Okay, so X is 1. Okay, in 5 observations, the probability of an event of interest is 0.5, 0.1. So the pi, or the probability of this event, is given as 0.1. So now we are calculating the probability distribution for the binomial probability for x. The variable is 1. So given the sample size n is equal to 5 and the probability pi is 0.1. So now we use the formula. So NCX. So this is the counting rule, okay, multiplied by the probability to the power of x, then multiplied by 1 minus probability to the power of n minus x. Okay, so now in this problem, now you can see that n is 5, so we write factorial 5. Then x is 1, so 1 factorial, so 1 factorial is 1. Then n minus x, so 5 minus 1 factorial. Okay, then probability is given, pi is given 0.1, so 0.1 to the power of x. So x is given 1. So 0.1 to the power of 1. Then 1 minus pi. So 1 minus pi value, the probability is 0.1. So to the power of n minus x. So n is 5, x is 1, so 5 minus 1. So if you do this calculation, so now your probability of x is equal to 1 is the final value given here. All right, any questions, let me know. So this is basically, once you know the equation, the binomial equation, so identify from the problem, so what is the variable, what is the sample size, and what is the given probability. So from this, you will be able to calculate the binomial probability for the given variable. Is that clear? Any questions? If all of you are listening, please take note that your end of term examinations, there will be 5 short answer questions for 40 marks. Okay, there will be 5 questions for 40 marks, and 3 big questions. Okay, so you can have 5 short questions. So for 40 marks, and there will be 3 long questions. So this will be for 60 marks. And you can expect one of the long questions from the discrete probability distributions that includes binomial distribution and Poisson's distribution. So factorial 5 over 1 minus factorial. So factorial 5, you can write it as, I clear this and do, is that okay? Okay, so factorial 5, I can write this as 5 into 4 factorial. Okay, over 1 factorial is 1. So 5 minus 1 factorial, you can write it as 4 factorial. Okay, so when you write like this, now I can cancel out this 4 factorial and 4 factorial. Okay, so you will have only 5 by 1, so that means 5. Is that clear, Leaping? All right. Okay, so we can look at another example of calculating the binomial probability. So I was telling you that this discrete probability is important exam point of view. So you will be able to get one long question from this discrete probabilities, which includes both the binomial and Poisson's distribution. All right, so let us look at another example. Now this example reads, okay, if the probability of invoice payment being Okay, a late is 0.01. So the probability of an invoice getting late is 0.1. So what is the probability of one late invoice payment in a group of 4 invoices? Okay, so here N is obviously the number of trials, 4 invoices. So X, you're referring to one late invoice. So X is 1. And the probability of the invoice getting late is given. So the probability pi is given as 0.10. So now we have all the information to calculate binomial probability. So now what is the probability of X is equal to 1? So given N is equal to 4 and pi is 0.10. So now the formula for the binomial distribution is NCX, then pi to the power of X, then 1 minus pi to the power of N minus X. Okay, so this is the binomial distribution mathematical formula. So we know what is N, X, and pi. So substitute everything back into the expression, then you can calculate. So you can see that the final answer for this is there is a chance of probability of 0.29 or 29% that one late invoice payment will be in a group of 4 invoices. So the probability of one late invoice will be around 29% or 29.2% in a group of 4 invoices. Okay, so the probability varies if the sample size varies. Okay, and also if the probability of given probability varies. All right. So what is important is that given the required information, how you can estimate the binomial probability distributions applying the mathematical formula. All right. Any questions or any question on this? Any doubts? All right. So if you have no questions, then I clear this. Then let us look how the shape of binomial distributions will. So the the shape of the binomial distributions depends on both the probability pi and the sample size n. Okay, so depending on n and the probability, so the binomial distribution shape will change. So for example, in one of the previous examples, so n is equal to 5 and the probability pi is equal to 0.1. So the probability of 0 will be, so point something here, you can see. The probability of 1, probability 2, probability of 3. So when the sample size is 5 and the probability is 0.1, the binomial distribution shape can be something like this. So you can see we are dealing with a discrete variable. So therefore you don't get a continuous curve-like thing. So what you have is the probabilities as okay, discrete numbers with gaps. So you can see X is not continuous. So 0, 1, 2, 3, 4, 5. X is discrete. So similarly, the shape of the distribution will change depending on the sample size and also the probability. Now for the same sample size, n is equal to 5. So now for a probability of 0.5, so you may get a different shape of the binomial probability distribution. So the shape can vary. Okay. So this is just to further dig into the formula. So how the shape of the binomial distributions will change given the sample size variations and also given the probability variations. All right. So this is not very important exam point of view. The calculation part is important. Okay, so for binomial distributions, you can also calculate the mean and the variance and the standard deviation. So you can see for the binomial distributions, the mean or the expected value of the population. So we are dealing with population mean, okay, is simply n into pi. So because we know n the sample size and pi the probability distribution, so we know both. So the calculation of mean is straightforward and it is simply n into pi. Then the standard deviation variance is sigma square. So the formula is n into pi multiplied by 1 minus pi. So sample size multiplied by the probability given multiplied by 1 minus probability. Now, if you take the square root of the variance, so if you take the square root of variance, so you will get the standard deviation. So standard deviation sigma is the square root of variance. All right. So for binomial distributions, this is how we can calculate the mean, variance, and standard deviation. So these formulas are also important. So normally for a big question, when a question is asked, so you will be given n and pi, okay, and you will be asked to calculate probabilities of x, okay. So in addition, as the big question will have a large number of small questions. So one of the question is you can also ask to calculate what will be the mean for the binomial distribution. What could be the standard deviation for the binomial distribution. So therefore you can use these formulas appropriately and do the calculations. All right, I move on to the next one. Okay, so the binomial distribution characteristics. So for example, you're calculating for the previous examples, what will be the mean and standard deviation. So given n is equal to 5 and the probability pi is equal to 0.1. So what will be the mean or the expected value? So n into pi, that is 5 into 0.1, that is 0.5. So then what is the standard deviation sigma? So the formula is n pi into 1 minus pi and the square root. So if you do the calculation, you will get the standard deviation for the binomial distribution. So depending on the values, so here n is equal to 5 and the probability is 0.5. So then the mean is 2.5 and the standard deviation is 1.12. So you can see here for the first set of data, okay, the mean and standard deviation is, mean is low, standard deviation is low. So similarly for the second set of data, mean is higher, 2.5. The standard deviation is also higher. All right, so this is how we can calculate for the binomial distribution, the mean and standard deviation. So to sum up, under what conditions we can use binomial distribution. So under what conditions we can use the binomial distribution is explained under the 4 categories. So you need to have fixed number of observations and, okay, so you need to have fixed number of observations and the observations must be mutually exclusive and collectively exhaustive. And you need to have the probability pi, and this is constant from observation to observation. So the probability will be constant. And the last one is any observation, the value of any observation is independent of the value of any other observation. So when you're dealing with x, so we know the probability of x, we are writing 0, 1, 2, etc. Okay, so these probabilities are independent from each observation. All right, so under these conditions, we can apply binomial probability distribution. Then what is the formula to apply the calculate the binomial distribution? So the formula to apply the distribution is binomial distribution is this. So simply NCX multiplied by probability to the power of x and 1 minus probability to the power of n minus x. So I'm just revising this to make sure that your concepts are reinforced. Then we have seen how to calculate given the required values, and the shape of the binomial distribution depends on the probability and the sample size. Then for binomial distribution, we can also define what is the mean, how to calculate the mean and standard deviation. All right. So then we move on to the next discrete distribution, which is the Poisson distribution. So under what conditions we'll apply the Poisson's distribution? So Poisson distribution will be used when we are interested in the number of time an event occurs, okay, in a given area of opportunity. So you can see the difference between Poisson's and binomial distribution once we look at the mathematical model of Poisson distribution. So here the idea is we are interested in how many number of times an event can occur once you know the area of opportunity, once you know some information related to the event. Okay, so we apply the Poisson's distribution when we know the events occur at random. Okay, so the events they occur independently of each other. Okay, so they are independently of each other, and the average rate of occurrence remains a constant. So this is important. So this is where the average number of events per unit, we define this with a symbol lambda. So lambda is the symbol which is used in Poisson's distribution, and this lambda refers to the average number of events in a unit. So, and the Poisson's distribution also requires the condition that, so there is zero probability of simultaneous occurrences. All right, so under these conditions, we apply the Poisson's distribution. So we have we are not discussing about the pi. So we are not discussing about the sample size like in binomial distribution. So let us look into the formula related to Poisson's distribution. I think Cheng Tek Meng is asking me about the slides. I think the school is asking the UCD, okay, the permission to upload the slides, and I think you will be able to get the slides very soon. But don't worry about the slides, because there's a PDF notes uploaded onto the Brightspace. That notes contains all this information in more summarized format. So the slides are mainly, for more visual experience, but the content is the same. All right. So mathematically, we can write the Poisson's distribution. So the probability of occurrence of an event X is exponential to the power of, so here you are getting a new mathematical constant E. So E is known as the exponential constant. This is also known as Euler's number. Okay, so exponential power of minus lambda, then lambda to the power of x over factorial x. Okay, so here the value of E is a constant. The value of this constant is 2.71828. So you can use this value when you are doing the calculation of Poisson's distribution. So in Poisson's distribution, we will have the value of lambda. Okay, so we know the value of this lambda. Okay, so talking a bit more about this exponential or E value. So basically it is the base of the natural logarithm. So in mathematics, we do logarithms, and also you can, what exactly this E is. So the exponential value E is, so we can write the value as limit, okay, 1 plus 1 over n as n tending to infinity. So when the n value approaches infinity, okay, the sum of the values of 1 over 1 plus 1 over 1 plus 1 over n to the power of n. So the value of this as n approaches infinity is given as the exponential number E. So the value of this is 2.71828. It is a constant, so it will never change. So when you're calculating the Poisson's distribution, so this number, the exponential number or the Euler's number coming into the formula. So what we know in this is to calculate by Poisson's distribution, we know lambda. So we have defined what is lambda. So lambda is the number of events per unit which is given in the description of the problem. So once we know the lambda, then we'll be able to calculate the Poisson distribution formula to know the Poisson probabilities. So when you are calculating the Poisson probabilities, so the mean is simply the lambda. Okay, so the mean value is simply equivalent to the number of events per unit which is given in the problem. Then the variance is sigma square. Sigma square is simply lambda. And what is standard deviation? So standard deviation is square root of lambda. So you can see that for Poisson's distribution, the mean and standard deviation values are simply one is lambda, the other one is square root of lambda. So lambda, as we know, are the expected number of events. So we can understand this, we can apply this formula once we go through an example. So let us go through an example. So here we can read this. So the mean number of customers who arrive per minute at a bank during noon to 1 p.m. So from 12 noon to 1 p.m. Okay, in this hour is 3.0. So here the lambda value is given. Okay, the expected number of events. So between 12 to 1, you expect 3 customers arriving in this hour per minute. Okay, so 3 customers per minute arrive at the bank, okay, between 12 to 1 p.m. So now you are asked to calculate what is the probability that 2 customers arrive in a given minute. So here X is the variable for which you want to find out the Poisson's probability. So now we write this mathematically, the probability of X is 2. Okay, so given lambda is 3.0. So what is the probability of 2 customers arriving? So given that the expected number of customers per minute is 3 between 12 noon to 1 p.m. So here, this is a case for Poisson's distribution. So we can't apply the binomial distribution here because we don't have the probability pi and we don't have the sample size. So here what we have is the expected number of events per unit. So in this case, the expected number of customers arriving per minute during the time 12 noon to 1 p.m. is 3. So that is the lambda given. So this is a case for Poisson's distribution, and we apply the formula. I think you guys can calculate this. So E value, you have to use 2.7182. So use E value, okay, it is given. So 2.71828 is the exponential value. So if you do this calculation, I think you will get 0.2240. Okay, so you need to use your calculator and do this. So please note here the sign is -3, -3.0. So when you're calculating using your calculator, so you can write this as 2.718. So this is exponential. So you can use brackets, then you use 3.0. So otherwise your calculator may give some error. Otherwise, you can also write down this exponential power of -3.0 as denominator. Once you take this value to the denominator, the exponential value becomes positive. So once you take down this denominator, this -3 becomes +3. So you can write 3 square, as we know, is 9. So 9 over. So you are taking down exponential power -3.0, taking down, and it becomes exponential power 3 positive. So this is, you can easily calculate using your calculator. So 2 factorial is 2. So once you do this, then you get the probability of 2 customers arriving every minute, okay, during 12 noon to 1 p.m. Is that clear, guys? Any questions? So CPT is asking me how to calculate. So how to calculate okay, there's an online calculator. You can try to do the exponential also. Otherwise, your calculator will have the exponential button. Okay, if you're not very sure, then you can use the number 2.71828. Then you can rise to the power of 3. So there will be exponential button, E button, in some scientific calculators. So if you don't have the exponential, never mind, you can just type in 2.71828. So then you can take, so just type in your calculator 2.71828. Okay, so you are to the power, okay, then use 3. So you know how to rise any number to the power, right, using your calculator. I think in your calculator, the symbol probably looks like x to the power y. So I think the button will have the symbol x to the power y. Is that clear, Septianti? All right. So I think if you try a couple of times, then you will feel comfortable. Okay, so now let us look at the graph of Poisson's distribution, probability distribution. So here the value, the probability distribution depends on the lambda value. Okay, so for a variable x, as x varies, so you can find out what is the probability of X for a given lambda. So because the Poisson's distribution requires only lambda and X for calculation. So once you know lambda, then you can choose X as a variable, and then you can calculate the probability of X for Poisson's probability. Okay, then you can plot X versus, okay, probability of X. So depending on lambda value, so the graphs, Poisson distribution graphs may differ. So they may have different shapes based on lambda value. Okay, we can see, I think in the next slide, a couple of, when the lambda is 0.5, okay, so you can see the Poisson's distribution shape, something like this as shown here. So similarly, when the lambda value increases, okay, so the Poisson's distribution, the shape changes. Okay, so it depends on the parameter lambda. All right, so this is about Poisson's distribution. So Poisson's distribution, I just go back. So what is required for Poisson's distribution is that you need to know the lambda value. So the lambda value is the number of events per unit. So once from the given description of the problem, so you can identify whether the problem falls into Poisson's distribution or binomial distribution. So for binomial distribution, you need to know n and pi. For Poisson distribution, this number of events per unit, that is lambda, is required. Okay, so once you know lambda, then this is the formula we use to calculate the Poisson's distribution. Then for Poisson's distribution, the mean and standard deviation will be quite straightforward. So the mean is equivalent to the expected number of events per unit, that is lambda value. Then the variance is also equal to lambda. The standard deviation is the square root of lambda. All right. So this is an example how you can calculate the Poisson's distribution. This is the, okay, the shape of Poisson's distribution depends on the lambda value. So this is the summary of what we have done. So we have looked into the discrete probability variables. So where the variable is a discrete, means it is a full number, whole number. So 0, 1, 2, 3, etc. So we can expect, we can calculate the expected value for the discrete probability distribution, then the standard deviation for the probability distribution. And we have looked into two distinct probability distribution. One is the binomial probability distribution, and the other one is the Poisson's probability distribution. So we have looked, these two distributions are two different mathematical models. So we have looked into the related equations, and also we know how to calculate for binomial distribution the mean and standard deviation, and similarly for the Poisson's distribution, the mean and standard deviation. Yeah, that's the end of this topic. So we summarize into the flow chart here. So the probability distributions, so you can calculate the expected value or the mean. So you can also calculate the variance or the standard deviation. So the standard deviation is nothing but the square root of variance. Okay, so most of the time what we need is the standard deviation. Okay, so if you have fixed number of observations n, and for each observation you know the probability pi. Okay, so if you know this, then you also know the probability of success is constant for all observations. Then we go for binomial distribution. Okay, if this scenario doesn't exist, you don't have fixed number of observations and you don't have the probability of success or failure, then we go for probability distribution. Okay, so if you there's another category which is hypergeometric distribution, and this we are not discussing. So we are focusing only on Poisson's distribution and binomial distribution. Because these two distributions find a large number of applications in business studies. All right. So this is the summary of the topic on discrete probability distributions. So discrete is the term. All right, let us look into some examples, some questions. Now, spend some time, a couple of minutes to go through the given problem. So here there's a data is tabled. So number of accidents daily is given 0, 1, 2, 3, 4, 5. And the probability of each variable is given. So the probability of 0 accidents is given as 0.1. So probability of 1 accident is given as 0.2. Then the probability of 2 accidents, okay? So the total probability will be 1. So the total probability is 1. So for this data, you're asked to compute the mean number of accidents per day and also compute the standard deviation. And the last question is what is the probability that there will be at least 2 accidents in a given day? Okay, so the last part you can write it as, so what is the probability of X at least? So we can write this as greater than or equal to 2. So you need to find out what is the probability of at least 2 accidents in a given day. Means we need to calculate probability of X greater than or equal to 2. All right. So is the problem clear to you? So we are dealing with a discrete probability distribution. Okay, so part C, mathematically, we can write it as probability of X greater than or equal to 2. Now to first to calculate the mean, okay? So to calculate the mean, what you need to do is you have to just prepare another column here, then multiply this column with probability of X. So prepare another column. So you multiply 0 with 0.1. So you get 0.00. So then you multiply 1 with 0.2. So you get 0.2. So like this, once you get the mean, you get as sum of this X and probability of X. I'll show you in the next slide how the calculations can be done. Okay, so you can see this is what is the given data. X is given us, okay? The probability of X is also given to us. So to calculate the mean, so the formula is for the discrete probability distribution. So we are not talking about binomial distribution or Poisson's distribution. So what we are talking about is a simple discrete probability distribution. The data is given to us. So for this set of data, we are calculating the mean. So the expected value or the mean. So to do this, because the tabulated data, so we prepare another column So we multiply x with probability of x. Then you add up this sum of x into probability of x. So if you add up this now, okay, so I think 0.2 plus 0.9 is 1.1. So 1.1, 0.45 is 1.55, plus 0.2 is 1.75, plus 0.25 is 2.0. So the sum of x into probability of x is 2.0. So that is the mean number of accidents for the given discrete probability distribution. So this is how we can estimate the mean number of accidents. So for the given data. All right, so this type of question can be asked for a short answer question for 5 marks or for 8 marks. Okay, so the next part of the question is calculating the standard deviation. So to calculate the standard deviation, so you need to prepare another column. So where you, once you know the mean value, so you are preparing another column x minus mean the square. So for the first one, 0 minus 2. So this is 0 minus 2 square. So 0 minus 2 whole square will give you minus 2 square, that gives you 4. Then for here, okay, x is 1. So 1 minus 2 whole square. Okay, so 1 minus 2 whole square is minus 1, minus 1 square is 1. Okay, then for the next one is 2 minus 2 whole square. So 2 minus 2 whole square, you get 0. So then 3 minus 2 whole square. X is 3 here. So 3 minus 2 whole square. So then here you are using 4 minus 2. So x is 4 and mean is 2. So 4 minus 2 whole square. Then here x is 5. The mean is 2. So 5 minus 2 whole square. Okay. So you will get the numbers like 41041. Okay. So the total of this standard deviation. Okay. Now if you take, this is one column, x minus mean whole square. So now you need to prepare another column. So another column, what you are doing is you are multiplying x minus mu whole square with probability of x. So if you name, this is column 1, column 2, so column 3, column 4. So column 5 will be, so you're multiplying column 5 to get, okay, so column 4 multiplied by the probability of x, so column 2. So C4 multiplied by C2. Okay, so you're multiplying x minus mu whole square into probability of x. So that is column 2. X minus mu whole square is column 4. So once you do the multiplication, so 4 into 0.1, 0.4. So 1 into 0.2, 0.2. So then 0 into 0.45 is 0. Then 1 into 1.5, 0.15. Okay, so you get this column, the data. So you find out what is the sum of this data. Okay, so you can see the sum of this data 0.6, 0.75, 0.95, then 1, 1.4. So you get the sum of this data as 1.40. Okay, so that gives you the variance. So sigma square is, okay, sum of xi minus mu whole square into px. Now if you take the square root of this, so sigma will be square root of 1.4. So this will give you the standard deviation for the data as 1.18. Okay, so I just repeat the answer here. So sigma is 1.1832. Then the last part of the question is, what is the probability of uh, at least 2 accidents on a given day? So that means probability of X greater than or equal to 2. So to know probability of greater than or equal to 2, so we know probability of 2 is 0.45. Probability of greater than 2 is probability of 3, 0.15. Okay, so you need to add up all the remaining probabilities. So if all these probabilities, when you add up, so you will get probability of X greater than or equal to 2. So that means the probability of having more than 2, at least 2 accidents will be 0.70. All right, so this is how when we have discrete data and their probabilities, so we can calculate the mean, standard deviation, and also you can calculate the probability of occurrence for any given set of variables, for any range of variable. All right, I'll pause here for a minute. Let me know if you have any questions. Guys, any questions, any doubts? So if you have no questions, then I clear this. All right, thank you, Chikai. Okay, so let us look at the next question. So this is a similar question. So let us read through. So the manager of the commercial mortgage department of a large bank has collected data during the past 2 years concerning the number of commercial mortgages approved per week. So the results from these 2 years means 104 weeks given. So the consolidated data is given. So here the data is the number of mortgages approved per week and the frequency. Then okay. So 0, no mortgages approved. How many number of times? 13 times. So 1 mortgage is approved how many number of weeks? 25 weeks. So this data is available for us. Now from this data, so for this distribution, so you're asked to again the same things, compute the expected number of mortgages. So that means you're asked to calculate the mean of the mortgages approved in a week. Then you're asked to calculate the standard deviation for this data. Then what is the probability that there will be more than 1 commercial mortgage approved? So that means you need to calculate what will be the probability of X greater than or greater than 1. Okay, there'll be more than 1 commercial mortgage. So we don't put equality. So we just write probability of X greater than 1. So when we say probability of X is greater than 1, so you need to add up what is the probability of X greater than 2, 3, 4, 5, 6, and 7. So all these probabilities you need to add up. Okay, so this question is very similar to the previous one. So the previous one we have seen, okay, how this can be done using preparing the columns like this. So for the next one, okay, I just prepared some Excel sheet and tried to put Okay, so what is given is that the title is not correct. So this is the probability approved, not arrivals, but approved. So the frequency of approvals is given. Okay, the frequency is given. So from the frequency, you need to find out the probability. So the data doesn't give you the probability. So you need to compute the probability. So how to get the probability? So the total number is 104. So 104 weeks. So if you divide the 13 with 104, so you will get the probability of zero approvals. Okay, so the probability of zero approvals is 0.125. So 13 over 104. Then the probability of one approval is 25 over 104. So you get 25 over 104, you get this number. Then the probability of two approvals is 32 over 104. So you get this one. So like this, you can prepare a column for probability calculations. So probability is the frequency of occurrence over the sample space. So the sample space in this case is the total number of weeks, which are given as 104. So out of 104 weeks, in 13 weeks, there is no mortgage approval. So zero mortgage approval. So the probability is 13 over 104. So you will get 0.125. So you have to prepare the column, probability column from the given data. Okay, so the total sample space is given, the frequencies are given. So therefore you can calculate the probabilities. So once you know the probabilities, then you are multiplying the column 1. So this is now your column 3. So X into P. So the column 4 gives you the multiplication of column 1 and 3. Okay, so 0 into 0.125, you get 0. So 1 into 0.240384. So you get, okay, so you're multiplying the variable with its probability. Then you prepare this column, then add up all these things. So that gives you the expected value or the mean of the approvals, mortgage approvals for the given set of data over 104 weeks. So in this case, I think you will get expected value is 2.1058. So you need to add up all the columns. So then you have to prepare another column here. This column is X, means number 1 column, minus expected value of X. So this is what we calculated, expected value of X, or the mean, which is 2.1058. So from every row, so you have to do this calculation. X minus expected value of X whole square. So this is the whole square multiplied by the probability. So we know the probability is column 3 here. Okay, so you can fill up the values and you add up all the values you get and take the square root, and that will give you the standard deviation for the given data. So in this case, the standard deviation is 1.4671. Okay, so the third part of the question asks you, so what is the probability that there will be more than one mortgage approval? So there is more than one mortgage approval means, so you have to add up all these probabilities greater than 1. So you add up all these probabilities. Okay, so I use a different color. So you need to add up all these probabilities. So which represents the probability of X greater than 1. So if you add up now, probability of X is equal to 2 plus probability of X is equal to 3, okay, etc., etc. So once you do this, so you will get 0.6346. Uh, yeah, Ang is asking, do we need to show the working for each calculation? Yes, in the exam, you need to show for each calculation. Sure, sure. You can also, but once I go back to this previous slide, I think all this work annotations will go. All right, so this is the question. All right. Then I move on to the next question. So we have seen, okay, the next question on discrete random probabilities. Okay, so here we have a pair of fair dice is rolled. So let X denote the sum of the number of dots on the top faces. Okay, now you're asked to construct the probability distribution of X. And what is the probability of X greater than 9? So basically you are throwing two dice and you're counting the numbers on each throw. Okay. And you need to find out, you need to first construct the probability distribution for X. So when you throw dice, so what will be your sample space? So first we need to know the sample space when you throw two dice. So when you throw two dice, the sample space, I think I'll show you in the next slide. Okay, so this is the sample space you can expect. So when you throw two dice, okay, both can show both 1, 1. The first trial can be 1 and the other one can be 2. So you can see this is the total sample space. So there will be 36 observations. Okay, the sample space is 6 square. Okay, so the first die can give 1, the second die also can give 1. Otherwise, the first die is 1, the second die is 2. The first die is 1, the second one will be 3. So like this, the total sample space or the total outcome in when you throw two dice will be 36. So the sample space. And you know all these numbers here. Okay, so now let us do the calculations part. So the first part is you're asked to construct a probability distribution. So probability distribution means you need to know the minimum value which you can see here is 1 and 1 is 2. Okay, so the maximum value you can use 6 plus 6, that is 12. So that means when you throw two dice, so the minimum you may get 2, the maximum you may get 12. So your X will vary from 2 to 12. So it can have a range of 2 to 12. So when X is 2, okay, when X is 2, so how many times you will get 2 from the sample space? So you can say that the 2 is possible is only once. So the first die is giving you 1 and also the second die is also giving you the 1. So there's only one probability, okay, one occurrence in the sample space for 2. So the probability for 2, you can write it as 1 over 36. So 36 is the sample space. 1 is the probability of occurrence of the number 2. So similarly, how many times you will get 3? So you can see 3, the probability of getting a 3 is 1 and 2 is probability, and 2 and 1. So there are only 2 times you can get 3. So what is the probability of X is 3. So you can write 2 over 36. So like this, we can calculate the probabilities for every number when you throw 2 dice, and you can see that the probability of getting the numbers vary from 2 to 12. So we can prepare a table like this. So X and the probability of X for this case. Okay, so when X is 2, the probability of getting a number 2 when you throw 2 dice is only once. So the probability is 1 over 36. Okay, so what is the probability of getting number 3? So there are 2 times we have seen. Okay, one is the first die gives you 1, the second die gives you 2, or the first die gives you 2, the second die gives you 1. So there are only 2 times you can get out of 36 possibilities. So the probability is 2 over 36. So similarly for 4, you can get 3 times. So you will get 1, 3. So you will get 3, 1, and you will get 2, 2. So there are only 3 times you may get the probable number 4. Okay, so the probability is 3 over 36. So like this, you can prepare this an event of getting 2. What is its probability? So the total of getting 3, what is its probability? So like this, from 2 to 12, you can calculate the probabilities. So this is what is meant by constructing the probability distribution X versus the probability of X. Is that clear, guys? All right. Oh, not understood. Okay. So if you have not understood, I'm sure. Okay, I'll go back to the problem. Okay, I'll go back to the problem. So what you're doing is you are throwing 2 dice. So 2 dice you're throwing. Okay, and X represents the sum of the number of dots on the top spaces. So when you throw the 2 dice, so you know each time you can count what will be the total. Okay, so you are asked to construct the probability distribution for X and probability of X. So when you throw a pair of dice, so you may get the sample space. I can show you from the next slide. Okay, so the first die can give you 1, and the second die also you get 1. Otherwise, the other probability is the first die will give you 1, the second die gives you number 2. So the first die gives you 1, the second die gives you number 3. So similarly, the first die is 1, the second one gives you 4. So the probability is for the first die getting 1, and the second die is getting all the other variables. So the totals, there are 36 outcomes like this. Is this part clear, Septiani? Okay, so this is just to calculate the total sample space, which is 36 outcomes. So when you throw a pair of dice, so the outcome will be 36. So now we need to calculate probability of getting the total. Okay, so what is the total of getting 2 when you throw 2 dice? So the 2, there is only one way you can get. Both dice must show 1. Right? So there is only one time you can get X is equal to 2. So the probability of getting a 2 when you throw a pair of dice, the total number is 2 is 1 over 36. Okay, the next one, what is the probability of getting a number 3? So the total of 3. So total of 3 is, there is one here and there is another one here. So you get 2 times a total of 3 when you throw a pair of dice. So the probability of getting a total of 3 is 2 over 36. So like this, you can find out for every number, okay, from 2 to 12. So this is the probability distribution table. So when the total is 2, the probability is only once. The total of 3 happens 2 times. So similarly, the total of 4 will get 3 times. Okay, so this is the probability distribution for getting a total and its probability. When you add up all these probabilities, you will get the total probability will be 1. Okay, so X is the random variable. All right. Okay, the second part of the question is, what is the probability of event X is greater than or equal to 9? So greater than or equal to 9 means, so you need to add up all these probabilities. Okay, so you need to add up these probabilities. So greater than or equal to 9 means it could be 9 or 10 or could be 11 or 12. So from this table, so probability of getting X is greater than 9. So you can combine all these values. So once you add up, you can see that the total probability of the sum getting greater than or equal to 9 is 27.77%, or you can approximately say it is about 28%. I think Cheng Tekmeng is asking, will this be an exam question? Okay, I pick up this question mainly because this was asked in one of the past exams. So this was an exam question in the past. So probably it may not be repeated, okay, unlikely. So it was one of the past exam questions for about 10 marks. All right, so I move on from here. So then, okay, next let us look into binomial distribution examples. So the binomial distribution examples, just recap. So the formula, okay, so probability of X given N and pi. So number of observation or the sample size and the probability of observation. So the formula involves the combination NCX. Okay, so this is the counting the probabilities, counting the numbers, sample space. Okay, so multiplied by the probability to the power of X and 1 minus probability to the power of N minus X. So we looked into this formula. So probably you might have got good familiarity by now. So now let us look into an example. Okay, so here these are simple calculations. So you are asked to find out when N is equal to 4 and probability is given as 0.12. Okay, so consider this is sometimes we refer the probability with pi, and in some cases it will be given as p. Okay, so the probability pi is given as 0.12. So then you're asked what is the probability of X is equal to 0. Okay, so now you can calculate using the binomial probability distribution, because we know N is given and we know the probability is given. So we use the formula. Okay, so probability of X getting 0 is, we need to first do the combinations, the sample space, factorial N over X factorial into N minus X factorial. So N is 4, so we are writing 4 factorial. So X is 0, so we are writing 0 factorial. And I told you earlier that 0 factorial is 1. Then 4 minus 0 factorial. So 4 minus 0 factorial is equals to 4 factorial. So therefore, actually, you can cancel out this 4 and this 4. And factorial 0 is 1. So the whole thing becomes 1. So the whole calculation will give you a value of 1. Okay. So then you need to, probability pi is given 0.12. So 0.12 to the power of x. So x is 0. Okay. So anything to the power of 0 is 1. So 0.12 to the power of 0 is also give you 1. So then you have to take 1 minus pi. So 1 minus 0.12, so that is 0.88. So to the power of n minus x. So n is 4, x is 0, 4 minus 0. So that means to the power of 4. So if you do this calculation, so you will get 0.5997. Is that clear? So we are just applying the binomial probability expression and we are just calculating for the given values. Any doubts or any questions? Okay, so similarly, I'm not showing you the values for calculation for this when probability of x is equal to 9. So you will get the answers for B, C, D, you can note down. Okay, so these are given the values of n and pi, the probabilities. So calculating the probability of an event for a given value of x. So we can use the binomial expression. So this is the equation, then we can calculate. All right, I move on from here to another similar question. Okay, so now we are asked to calculate the mean and standard deviation for the variable x. So in all the cases, so this is again binomial distribution. So n is given, the probabilities are given. Okay, so the mean is simply n into pi. Okay, so the standard deviation is variation of x. So the formula is square root of n pi into 1 minus pi. So we'll be using just these formulas to calculate. Okay, so for A, what is your answer? Mu is equal to 0.4. Yeah, that's perfect. N into 4 into 0.1. So that is 0.4. So what will be the standard deviation, sigma? So square root of n pi into 1 minus pi. So that means square root of, so n is 4. So pi is 0.1. Then 1 minus pi is 1 minus 0.1. So that is 0.9. So can someone give me the value for this sigma? So this is 4 into 0.1 is 0.4, 0.4 into 0.9 is 0.36. So you will get square root of 0.36. So what will be the square root of 0.36? Yeah, I think Chan gave the value. So it will be 0.6. Okay, so this will be the calculation for the first part. So similarly, you can calculate for the remaining parts. Okay. Okay, I clear this. Okay, so the calculation is shown for the first part. Okay, so the mean is n into p, so you get 0.4. The standard deviation, the formula is np into 1 minus p, so you get 0.6. Okay, so for part A, the answer is 0.4 and 0.6. Then similarly, you may note down for part B, part C, part D. All right. So I move on from here. So we are looking for binomial distribution. So we have calculated binomial distributions for the given data. Okay, now let us look at a practical example here. So here, a manufacturing company regularly conducts quality control checks at specified periods on the products it manufactures. So historically, the failure rate of LED light bulbs that the company manufactures is given as 3%. So 3% is the failure rate. So this is the probability pi. So pi is 3% means you can say pi is equal to 0.03. So 3 over 100, that gives you 0.03. Then you're taking a random sample of 10. So n is equal to 10 for this problem. Okay, so now you are asked to calculate the probability that none of the LED bulbs are defective. So when you choose a sample size of 10 and the historical failure rate is 3% or the probability is 0.03. So what is the probability that the X is equal to 0? So part A, we can write it as what is the probability of X is equal to 0. Okay, so the second one, exactly one of the LED light bulbs is defective. So we can write for the part B as what is the probability of X is equal to 1. Okay, so C is 2 or fewer of the LED bulbs are defective. So here you are looking at probability of X less than or equal to 2. So we can write, so probability of X less than or equal to, so we can write less than or equal to 2. Then what is the probability of 3 or more of the LED bulbs are defect? So we can write what is the probability of X greater than or equal to 3. All right, so given pi 0.03 and given the sample size 10, so we need to calculate probability of X is 0, probability of X is 1, then probability of X is less than or equal to 2, and probability of X is greater than or equal to 3. So is that clear, the problem and how to convert the given data into expressions? All right. So for this type of problem, then we can use the expression to calculate the equation which we have seen. We can use the same equation to calculate probabilities. So I clear this, then I'll show you the working. So here the sample size n is 10. So n is equal to 10. Then the probability is 0.03. So then we can use the binomial distribution formula. Then we can calculate what will be the probability when x is 0, when x is 1, 2, 3, 4, 5, up to 10. Okay, because the max sample size is 10, we can't go more than x is equal to 10. So x can vary from 0 to 10 only. So for each variable, so we can use the binomial equation and we can calculate the probability. Okay, so this is done using Excel. So from this table, now we can answer all the questions. So the first part of the question is, what is the probability of x is equal to 0? So you can straight away get the answer from your table. So probability of x is 0 is 0.7374. Okay, so you need to develop this type of calculation or this type of table. Next, what is the probability of x is equal to 1? So you know what is the probability of x is equal to 1 from here. So that is 0.2281. Okay, the part C question is probability of x is less than or equal to 2. So less than or equal to 2 means you need to add up the probabilities of, okay, these three. So you add up the probabilities of 0 plus probability of 1 plus probability of 2. Okay, so this is the probability of x less than or equal to 2. So if you add these three numbers, you will get the probability around 0.9972. So that means there is a probability of 99.7% that in a sample size, the defective LED bulbs will be less than or equal to 2. Okay. Next, the last part of the question is, what is the probability of the defectives more than 3 in a sample size of 10? So more than 3 means you need to add up all the other probabilities. So you can practically see that the probabilities are becoming 0. So when x is greater than 5, so all these probabilities are zeros. So probability of greater than or equal to 3 means only you need to add up these two numbers. So we need to add up only these two numbers. So practically you need to add up all the numbers, but because the rest of the numbers are zeros, so your probability of defects greater than or equal to 3 will give you 0.0028. Is that clear, guys? Any questions? Any doubt on this? Yeah, Satyani, you observed clearly as what happens is sometimes because rounding of the figures, so the last digit maybe sometimes you may get some variation. Okay, so now this why this 0.028 is coming is, so the calculation is simply made 1 minus 0.9972. Okay, so 1 minus 0.9972 will give you 0.0, because the total probability should be 1. So you will get 0.0028. Okay, so normally in the exams, your answer is either 0.0027 or 28. You will be given full marks. So when you do rounding of numbers, there may be some minor variations when you are adding up large numbers. Okay. All right. So this is how we can apply the binomial distribution for practical problems. All right. So just I would like to highlight you that, we do get binomial probability distribution tables. So for different sample size, actually, this is the sample size. Okay, so here you're calculating, this is your X. Okay, so when your sample size is 2, your X can be 0 or 1 or 2. Okay, so there are 3 possibilities. So then the pi values are given here, the probability values are given 0.1, 0.5. So for a set of probabilities, so using binomial probability distribution tables available, okay, these tables are available in different textbooks and also online. So you can also use these tables instead of doing the calculations. But exam point of view, because there will be definitely a question from the discrete probability distribution, you can't use the tables, but you have to show your calculations from the formula. But I would like to ensure you that there are tables available for both binomials and Poisson's distributions. So you can use the tables and also you can solve problems. All right. I clear this. So then I move on. So the next one is the Poisson's distribution. So Poisson's distribution, what is required is lambda. So that is the expected number of events. So depending on the problem, so we can calculate Poisson's distribution. So just for recap, I give you the formula and the description for this. Okay, so let us say an example can be lambda is given. So you're asked to calculate what is the probability of X is equal to 2. Okay, so you can use the formula exponential power minus lambda multiplied by lambda to the power of X over factorial X. So when X is equal to 2, factorial X is 1 into 2. Okay, when you calculate exponential power minus 2, okay, so the value you get is 0.0808. Then lambda to the power of X, so that is 2.5 square. So 2.5 square is 6.25. Okay, so if you do this calculation, so you will get the probability of X is equal to 2, assuming Poisson's distribution is so 0.2565. So similarly, when you can calculate when lambda is 8 and probability of X is equal to 8 will be, so you can apply the same formula. Okay, so when you calculate, the answer will be 0.1396. Online. So here we are straight away using the Poisson's distribution formula and doing the calculations. Okay, I'll be ending in another 2-3 minutes. Please bear with me. The next one is similarly. So the lambda is given for Poisson's distribution. So here you are asked probability of X is greater than or equal to 2. Okay, so when you have such a thing, so you have to calculate what will be the probability when X is equal to 0 and also when X is equal to 1. So we calculate using the formula when probability of X is equal to 0 and probability of X is equal to 1. Then because the question is asking you greater than or equal to 2. So all other probabilities when you subtract from 1, so you will get the probability of X greater than or equal to 2. So in this case, we can write 1 minus, so probability of X is equal to 0 plus probability of X is equal to 1. So the calculations are not shown using the Poisson's formula, but once you use for X is equal to 0, the probability for Poisson's distribution is 0.1353. So similarly for x is equal to 1, so you get 0.2707. So then the probability of x is greater than 2 will be 1 minus, so the addition of these two numbers. So that will give you a value of 0.5940. All right. So I think I'll stop here. Any questions? There are few more calculations required. I'll be able to do next session. Okay. And you guys may be knowing that, right? Saturday, there is a session at campus. So I'll be meeting you in campus. May I know how many of you will be coming to the campus? All right. I think if everybody comes, that will be nice. So we can have a face-to-face. All right. So I strongly encourage all of you to attend. I stop here. Any last minute doubts, let me know. So do you have any last minute questions? Otherwise, I can stop you. I blur my background. So if you have no other questions, then I'll see you tomorrow. So tomorrow the plan is to complete what we have seen is the discrete probability distributions. So tomorrow we'll go through the continuous probability distributions. And if the time permits, we'll also look into the confidence intervals. All right. Any other questions, let me know. So otherwise, binomial table, yes, Chami. So you can download this. You just type in Google binomial distribution tables. So you will be able to download those. What is your question? Exam, definitely no. But for your assignment, yes, but not for the exam. I think Saturday session is a mixed session. That means you can still access through the Brightspace. So I think basically instead of doing from home, I'll be doing it from campus. But if you attend, then of course the experience will be slightly different. Online. Okay, if you have no other questions, then I'll never mind if you can't come. I think you can still access through the Brightspace. Exams must go to campus. I'm not sure, but I guess unlikely. I guess your exam may be online. So I'm not very sure, but I think the PM will advise you on that. The exam unit will be advising you on that. But I guess they may go online for this time around. All right. Any other questions? All right. So if you have no other questions, then thanks for your patience, and I'll see you tomorrow again. And have a good night. Good night and bye-bye to all. All right, guys. So now I'll end the session for all of us. Thank you, guys.